So we continue talking about mu and sigma, parameters of normal distribution, and let's give the names for these two letters, and probably you already know these names. Parameter mu is called average, and for normal distribution, or sometimes just mean, for normal distribution it's computed as arithmetic mean. What's the meaning of the arithmetic mean? And let's talk a little bit more about the mu, right? So remember, mu is a measure of central tendency. So mu is where the highest density is. You can think about mu as a center of mass of your values. So what do I mean by that? Imagine that every value is just, for example, a metal ball or plastic ball which have the same weight. And then the position of this value is just the value itself, right? So the value defines the position. For example, if it's 170, it means it's 170 centimeters away from something, right? Then if you put a plate, for example, a metal plate, a plastic plate, a tree under this and fix the position, for example, glue them, then mu, it's a location of this little triangle which makes all these balls balanced, make all these values balanced. So it's a center of mass in physics. Okay, that's exactly the meaning of the mean. And that's the difference between the mean and the median that we learned in previously, right? So remember, median, it's the point which is exactly in the middle. For example, if you have 3 points, which looks like this, let's say it's 150, 155, and 185, for example, right? Then the median will be this point. But apparently, if you put these points to a plate and then try to balance them, the median will not balance them, right? So you will see that this is heavier tail. So mean will be located here, and it will balance these 3 values. So you will have 2 on the left, 1 on the right, but they will be balanced. So that's the meaning of mu. How to compute mu? How to find this position that is center of mass of your values? Well, it's actually simple. You simply take a sum of all these values and divide to the number of the values. So in this case, for example, when we talk about if we have a population of 3 values, which is almost impossible, but let's pretend like this. So then you take 155 plus 185 plus 150, and then you simply divide to 3. That will be the position of this center of mass. Okay. What about the sigma? Well, first of all, you see, although we use sigma, you can see that this is sigma squared, right? And sometimes we will use sigma squared, sometimes we will use sigma. Let's start with sigma squared. So what's the meaning of sigma squared? Well, sigma squared, this parameter is called variance. And the meaning of sigma squared is also quite simple. It's average squared distance from all values of your population and the mu and the mean. Okay. So let me illustrate this again. So this is the values. Let's find the mean first. You remember it's a center of mass, right? So this is our mean, mu. And then let's take one particular value, for example, this one. We simply measure how far this value is from mu by computing a difference between x1 and mu. And that's the first distance. Then we do it for the second value, and then we do it for all values that we have here. The problem is that this distance, will be positive, and this distance will be negative. So we cannot compute just average distance because average distance will be 0. But we are interested in magnitude, how far they are. We are not interested in this particular case in which direction they are distanced from mu. We are interested only on the distance itself. So therefore, to get rid of this sign problem, we simply square the distances. So we need to compute average squared distance. We already know how to compute average. We simply take sum of all values and divide to the number of these values, right? We simply take a sum of these squared distances and divide to the number of these distances, which is exactly the same as the number of values. And then this is just the same expression. I just, instead of d, I use the how we calculate the distances. This capital N, it's a size of population. You remember, these are parameters of population. We still talk about population, although it's a little bit simplification because in reality, we don't have access to population. In reality, we can't compute it, but this is the idea. So if we have access to population, this is how we're going to compute them. Now we can summarize it, right? So this is mean or average in this case. This is variance. And to compute sigma, we simply take a square root of variance which is we call standard deviation. So standard deviation is simply a square root of variance. And when you do computations manually, that's exactly how you do it, right? So first you compute the variance, and then you take a square root of the variance to compute standard deviation. Okay, so that's the meaning. Now you know how these parameters are computed. In the next video, we will try to rethink what normal distribution is.